All right, so what is a log? Well, yesterday we did exponential functions like y equals 3 to the x. We solved equations with them and we graphed with them. But what if we are needing to find the inverse of y equals 3 to the x? As we know, inverse equations are flipping x and y around. So we could just flip x and y around. X equals 3 to the y. Okay, but usually when we do the inverse, then we go and get y by itself, right? Well, this is very difficult to get y by itself by solving it. So instead, we write y by itself by using the logarithm. So we say y equals log base 3x. These two things mean the same thing. X equals 3 to the y is the same thing as y equals log base 3x. If you had me for Algebra 2, you may remember that the way I remember it is log little to the other equals, I just say greater because it's a g, but this little number, 3, to the other side, y, equals the number that I write bigger or greater. It's not necessarily a greater number, but that is this number here, 3 to the y equals x. So x equals 3 to the y. That's how I remember it. So use it if you want to. Okay? So we should know that y equals log base a x if and only if, which is IFF, x equals a to the y. And logarithms are only defined where a is greater than 0. So this number's got to be positive right here, the little number. It also can be 1. And x is also positive. So these two numbers have to be positive for the log to work. If you type into your calculator any log of a negative, you'll say error. Okay? You cannot take the log. Logs cannot be negative. You can't take the log of a negative number. All right. So the domain of any log, well, when it's just x right here, that is greater than 0. The range is all real numbers. The other thing we should talk about is when the base is e. E, just a number, okay? A special number that's used in different areas of mathematics. But the log base e of x is the same thing as the natural log of x. So ln is the log with base e. These mean the same thing. So if you see y equals ln x, and it helps you more to write this out so you understand it, that it's really e to the y equals x, then you can do that. Okay, so I guess I could write that. E to the y equals x. All right, so what are we going to do next? We are going to look at some specific examples. Okay? And these examples are on page 294. If you still have that open, you could see the directions. But really, we're just going to do 1 or 2 problems from each of these little sections that you need to do. So we'll start with number 11. These first problems just say, you're not actually doing the math, you're just writing it in a different form. It just says change each exponential statement to an equivalent statement involving a logarithm. So number 11 says 9 equals 3 squared. Yes, it does equal 3 squared, but they want us to write it in this form with a log. Log base 3, 9 equals 2. Because little to the other equals greater. 3 squared equals 9. So you'll have some where you're just writing it from one form to the other. All right, so we'll do 19 as well. Let's do log, this time giving it to us in log form. This might be even easier because we're just supposed to write it without log. So we just say little, 2 to the other side, 3 equals 8. 2 cubed equals 8. Okay, so you're starting off with even, so you'll do 12 to 26 even the same way as we just did 11 through 19. Okay, then you will move on to the next section, which says find the exact value without using a calculator. So for instance, let's look at 27 first. Sorry. 27 says log base 2 of 1. And you're just thinking in your head, 2 to what power is 1? Well, anything to the 0 is 1. So if you could just figure it out in your head right like that, you just write the answer. Okay? But what you're really doing is you're thinking 2 to what power, you could put an X there if you want, equals 1, and 2 to the 0 equal 1. All right, now let's look at 31. Log base 1/2 16. 1/2 to what power equals 16? Keegan's got it? -4. Well, because negative means we're flipping it around, right? So the negative says to flip it, and then 2 to the 4th is seed, so it would be -4. Okay, so sometimes you could figure it out in your head. Sometimes you may need to do something like we did yesterday, where you rewrite this with the same base so that you could solve it that way. Let's actually, real quick, what's number 29? Log 525. 2, right? 5 squared is 25, and so on. I'm going to let you guys go ahead and start the assignment. So instead of doing all the notes and then giving you this long assignment, I'm going to trick you and have you start the assignment now so it doesn't look so long later. Okay? So right now you should be able to handle 12 through 38 even based on what we've just talked about. Okay, so go ahead and try 12 to 38 even. Then we'll move on and talk about how to continue. If you think you can move on past 38, you're welcome to do that. But once most of us are to number 40, we will move on. So, hey, Sebastian and Will and Avery and Eli and Shane and Caitlin is gone, and Alex, said him. Anyway, you guys go to part 2 now. Now we're taking a look at 39. And it's just asking you to find the domain. We just have to remember that any log, whether it's log or ln, natural log, we can't take the natural log of anything unless it's bigger than 0. So we just have to make sure this is bigger than 0. What would x have to be to make sure it's bigger than 0? Say it again. Shannon? So you're saying 5 minus 3 is bigger than 0. That's correct. Anything smaller than 5 that's bigger than 0?
4, but then well, I guess like you have to do a little numbering.
That's Shannon talking. Oh, sorry. So all we really have to do is this. Whatever's in here, set it equal to 0 and solve it. So as long as x is bigger than 3, then you can plug x in. So the domain is 3 and up. That's all you're doing on these. You just have to make sure that this number cannot be 0 or smaller. So how about 41? Log base 2 of x squared. If you put a positive in for x, will this be positive? It's a simple question, right? Yes. If you put a negative in for x, will it be positive? Yes. So all numbers work for x here? Except for 0, because 0 squared will not be positive. And remember, it be 0. It's got to be bigger than 0. So the domain here would be everything except 0. Okay, so it can't be 0, but the squared made anything else work. So that one you just kind of think about. Okay, and we'll look at 43 just to do one more of these. 43, we don't care about anything else except what's after log, what we're taking log of. So don't worry about the 3 minus 2 on this one. All we're looking at is the x over 2 minus 5. We just have to make sure that that's bigger than 0. Okay, so you just solve that, add the 5 over, multiply by 2, and as long as x is bigger than 10, you'll be able to take the log of that. All right, so I think that now, note that starting at 40, we are doing multiples of 4 instead of every even. So it's every other even. So you should be able to do 40 really through 60 now. You've got a couple where you're just plugging things into a calculator, 52 and 56. Number 60, we'll see how many of you get that one. I'd like to try 60, even though we haven't done one like that yet. Okay, so I'm going to stop the video again, see part 3. If you need help with 48 or 60, they're right here. But now we're going to move on to 61. All right, 61 says to graph the function and its inverse on the same set of axes. Okay, so 61 is just f of x equals 3 to the x power. The inverse of an exponential is the log, so that'd be log base 3x. For us to be able to graph log, we need to be able to graph its inverse first. And by the way, you cannot exactly type this into the calculators that I checked out. Okay? You can't type a specific base on the log. You could just type log, which is base 10. Right, so the calculator is no log base 10. If you needed to type this and you really just wanted to do it on your calculator, the best thing for you to do would be to type its inverse. That will give you the inverse graph, and then just change all the x and y's around to make your graph, which is what we do to graph it anyway. Okay, I'm just going to do both without the calculator, because 3 to the x is just, well, when x is 0, y is 1. When x is 1, y is 3. And when x is negative 1, y is 1/3. So this is what 3 to the x looks like. That's the kind of graphs we did yesterday. Now I'm going to graph this, which is the inverse, and all I need to do is flip all of these ordered pairs around. This was the point 1, 3. So I'm going to plot the point 3, 1. This is the point 0, 1, so I'm going to plot 1, 0. And this is negative 1, 1/3, so I'm going to plot 1/3, negative 1. Okay? And that's how the inverse graph looks. And you might remember from the past that any graph and its inverse, if you think of the line y equals x, that is right in the middle. They're symmetric over y equals x. So if it looks like they are, then you probably did it right. Okay, so that's what you will be doing on 64. The next thing we're going to do is move forward to number 73. And this will be our last graph. And you will do 76, 80, 84, and 88 like this. But there are multiple steps on these, so we'll also need our notebook paper. 73. We are going to deal with this function. F of x equals the natural log of x plus 4. And they ask us these things. First, what's the domain of f? Well, we've already talked about how to do that. X plus 4 is greater than 0, so x is greater than negative 4, right? Okay, you just set whatever's in here greater than 0 to get your domain. B says to actually graph the function. Okay, so I'm going to go back to 73 on the graph here. I'm going to graph just to see what y equals ln x is, because ln x plus 4 is just going to be shifted left 4. So if we know what y equals ln x is, we could just shift them to the left. Now you are welcome, like I said, to use your calculator to graph y equals ln x. That one you could put right in there. Okay? You're welcome to do that whenever possible, but I'm going to do this the way that I had to do it in high school. Okay? So, and that is to remember that y equals ln x is the inverse of y equals e to the x. So, if I could graph y equals e to the x, which we did yesterday, when x is 0, y is 1. When x is 1, y is e, which is about 2.7. When x is negative 1, I remember yesterday it was about 0.36. So that is what y equals e to the x looks like. It's about the same as the graph up here, because e is almost 3. All right, but y equals ln, so this is y equals e to the x here. I'm going to graph y equals ln x by flipping around the ordered pair. So this one was 1, 2.7. I'm going to go 2.7, 1. This was 0, 1. So I'm going to go 1, 0. This is negative 1, 0.36. I'm going to go 0.36, negative 1, and there's y equals ln x. So for me to actually graph y equals ln x plus 4, I would just take all these points and shift them 4 to the left. 1, 2, 3, 4. That's right here. I don't know. Some of you probably like to do it all in the same graph. It's a little easier to shift on the same graph, right? Sometimes I like to go to a new graph so it doesn't look so cluttered, but it doesn't really matter to me. 1, 2, 3, 4. And 1, 2, 3, 4. And there we go. There's an asymptote right there, instead of the asymptote normally being the y-axis. So now that I've done part B, the graph, now I move on to part C, which says, from the graph, determine the range in asymptotes. Okay, so the range, well, this is going down forever, and really it is going up forever. It's just getting to forever slowly. Okay, so the range is all reals. And the vertical asymptote, we can see right here, is x equals negative 4. So that shouldn't be bad to answer. Part D says find the inverse. Okay, this, we need to do a little bit of algebra. Find the inverse of this. Remember, this is y equals ln x plus 4. So the inverse would be x equals ln y plus 4. Okay? And then I need to get y by itself. Remember, ln is log e. So this is just log e. So whenever you have an ln, just think this is log e. It's e to the x equals this. So you could use e to cancel ln. So e cancels ln on this side, leaves you with this, and you set the other side as e to the x, and now we could easily get y by itself by subtracting 4. Y equals e to the x minus 4 would be your inverse function. So if I want to write this in function notation, I would say f inverse of x equals e to the x minus 4. Okay, and then part E says find the domain and range of the inverse. Remember what we said yesterday, though. The domain of a function is the range of its inverse, and the domain of the inverse is the range of the function. If I just said that right. So the domain, the range of the original function is all real, so that would be the domain of its inverse. Just flip them around. So that part will be easy if you already have the domain and range. The domain of the original was x is greater than negative 4, so the range will be y is greater than negative 4. And then finally, they ask you to graph the inverse. So you could do this a couple different ways. You could just plug this into your calculator, y equals e to the x minus 4. Or you could graph it longhand. Or, what I'm going to do right now is, since I have the original graph right here, I'm going to graph its inverse by flipping a round ordered pair, so I don't even have to type it into the calculator. I'm just going to say this is, what was this? This was negative 3, 0. So I know I have 0, negative 3. This is negative 1 point something, 1. So that'd be 1, negative 1 point something. This is negative almost 4, negative 1. So I'm going to go negative 1, negative almost 4. And it looks like this. If I extend this a little bit, then it looks like a fish. And I can see it still looks like they're inverses because of that. And that's how you do this. Okay? So, again, feel free to use your graphic calculator to help you with any of these graphs or the matching on a couple of these that you have to match. But as far as finding the other things you need to find, hopefully you could use this guide to help you. Okay? The only other problems you have at the end, like I said, are equations. But they're going to be problems like this. 91. Just going to do this last one. Log 2, 2x plus 1 equals 3. You just use the log equation to set up your own equation without log. Little to the other equals this. 2 to the third is 8. You just have a simple equation to solve here. 8 is 2x plus 1. Subtract 1, divide by 2, and you get 7/2. So that's how you'll do the last section. Any questions? All right. Remember, stop at 100. Okay, guys, change the assignment to stop at 100, not 112, unless you want to do more, which might help you.